on the Agronomy Jigsaw project.
A Geographic Information System, or GIS for short, is a computer-based tool for displaying, analysing and capturing features and events that occur on Earth. From physical features such as lakes and buildings, to events such as floods and disease outbreaks, all of these can be mapped using a GIS. To operate a GIS, several components are required. Firstly, you need hardware, essentially a computer, on which the GIS software will run and where the data is likely to be stored. Additional items such as GPSs for capturing data in the field are also useful. Secondly, you need specific GIS software. This is what will allow you to display, analyse and capture spatial information. There are numerous software packages available. Lastly, and perhaps most importantly, you need data. Data is the core component of any GIS. Data comes in two formats, vector and raster. Vector data represents geographic features as points, lines or polygons. For example, points are commonly used to represent singular features such as town sites and bore locations. Lines to represent linear features like roads and streams, and polygons to represent areas such as property and administration boundaries. Raster data uses grid cells, arranged in columns and rows, to represent features. Raster data is commonly used for aerial photography and satellite imagery. GIS has many advantages and is used in a wide range of disciplines, including precision agriculture. Let's look at an example of how yield data is processed using a geographic information system. Firstly, display the raw yield data. You'll see that the data is in point form. Associated with each point is a yield value. The next step is to turn the vector point data into a raster image using one of several interpolation techniques. This turns the sparse yield points into a single continuous layer. Each grid cell contains a single yield value. The final step is to group the yield into different value ranges and give them different colours. This makes it easier to visualise where the low, medium and high yielding areas are. This is just one example of how GIS can be used in precision agriculture.